Welcome to a world where artificial intelligence and mobility converge in revolutionary ways. The rise of autonomous vehicles is reshaping transportation, ushering in an era where cars, drones, and even ships navigate independently without human intervention. These technologies promise greater efficiency, safety, and convenience, revolutionizing how we travel and transport goods. But how did we get here? From early concepts to cutting-edge advancements, we'll explore the pioneers, innovations, and challenges shaping the future of self-driving technology. Get ready to dive into the fascinating evolution of autonomous vehicles and discover what lies ahead. If you are enjoying this video, hit the like button, subscribe, and turn on notifications. Before we could even dream of self-driving cars, the invention of the automobile itself transformed human mobility. In the late 19th century, pioneers like Carl Benz and Henry Ford introduced gasoline-powered engines, replacing traditional horse-drawn carriages. This innovation made personal transportation more accessible and efficient, laying the foundation for modern vehicles. Ford's assembly line revolutionized car production, making automobiles a household staple. These early breakthroughs shaped the transportation industry, creating the stepping stones that eventually led to the possibility of autonomous mobility, a vision that is now becoming reality. The idea of cars that drive themselves dates back to the mid-20th century, with engineers experimenting with radar and radio guidance systems. During the 1950s and 60s, concept vehicles were developed with automated control, though they remained limited to closed environments. These early attempts, while rudimentary, sparked the imagination of researchers, planting the seeds for future advancements. With each decade, technological improvements in sensors and computing brought self-driving concepts closer to reality, culminating in today's sophisticated AI-driven vehicles capable of navigating complex roadways with increasing autonomy. The 1980s and 90s marked a turning point in autonomous driving, thanks to groundbreaking work by visionaries like Ernst Dickmann and institutions such as Carnegie Mellon University. Dickmann pioneered early autonomous vehicle prototypes, demonstrating their potential on test tracks. Simultaneously, research teams worldwide, including Mercedes-Benz and Stanford, developed sophisticated sensor-based driving systems. These early prototypes navigated controlled environments, showcasing the feasibility of self-driving technology. Their contributions laid the foundation for today's AI-driven mobility, setting the stage for modern innovations that are now becoming commercially viable on public roads. By the early 2000s, advancements in artificial intelligence and machine learning propelled autonomous driving into a new era. Companies like Tesla, Waymo, and Uber spearheaded research, integrating AI-powered decision-making into vehicles. These systems analyze real-time data from cameras, LiDAR, and radar sensors to predict and respond to road conditions. As AI grew more sophisticated, self-driving cars evolved from theoretical concepts into functional prototypes, capable of navigating urban environments with minimal human input. With ongoing improvements, AI is transforming mobility, making autonomous vehicles safer and more intelligent with each passing year. Today, the race for autonomous vehicle supremacy is led by major players in technology and automotive industries. Tesla's autopilot and full self-driving (FSD) systems are among the most recognized, while Waymo, a subsidiary of Alphabet, has pioneered extensive autonomous taxi services. In China, Baidu is leading the charge with its Apollo project, testing AI-powered transportation at scale. Cruise, backed by General Motors, is pushing forward with driverless ride-hailing services. As these companies refine their technology, competition drives innovation, bringing fully autonomous mobility closer to widespread adoption. Autonomous vehicles rely on an intricate network of sensors and AI-powered algorithms to navigate safely. LiDAR, radar, and high-resolution cameras continuously scan the surroundings, detecting obstacles, pedestrians, and other vehicles. This data is processed in real time, allowing AI systems to make split-second driving decisions. Advanced neural networks enable the vehicle to recognize patterns, anticipate hazards, and adapt to dynamic road conditions. These systems work in harmony to create an intelligent, self-sufficient mode of transportation that improves safety and efficiency on our streets. Autonomous vehicle technology has moved from research labs to real-world testing on busy urban roads. Companies conduct trials in diverse environments, exposing self-driving cars to complex traffic patterns, pedestrians, and weather conditions. Engineers monitor vehicle behavior, analyzing how AI systems react to real-life scenarios. Cities like San Francisco and Phoenix have become hubs for autonomous taxis, offering passengers a glimpse into the future of mobility. These ongoing tests refine AI decision-making, paving the way for safer and more efficient autonomous transportation systems in our daily lives. Autonomous trucking is revolutionizing the logistics industry by increasing efficiency and reducing operational costs. Unlike human drivers, self-driving trucks can operate 24/7 without rest, making long-haul transportation faster and more reliable. Companies like TuSimple and Embark are testing AI-powered freight vehicles on highways, showcasing their ability to navigate extensive road networks with minimal supervision. As technology advances, autonomous trucks could redefine supply chains, optimizing delivery routes and improving overall productivity while addressing driver shortages in the freight industry. The shift towards autonomous electric vehicles has increased demand for lithium-ion batteries, essential for storing energy efficiently. However, lithium extraction raises environmental and geopolitical concerns as global supply chains struggle to meet rising demand. Researchers are exploring alternative energy solutions, such as solid-state batteries and hydrogen fuel cells, to reduce reliance on lithium. As the industry seeks more sustainable options, advancements in battery technology will play a crucial role in shaping the future of autonomous transportation while minimizing environmental impact. As the demand for sustainable energy grows, researchers are developing alternative power sources for autonomous vehicles. Hydrogen fuel cells offer long-range efficiency, while solid-state batteries promise higher energy density and faster charging times. Additionally, solar technology is being integrated into vehicle designs, harnessing renewable energy directly from the sun. These innovations could significantly reduce the environmental footprint of autonomous transportation, paving the way for a cleaner, greener future where mobility is both intelligent and sustainable. The integration of autonomy into aerial transportation is reshaping how goods and people move through the sky. Drones are revolutionizing package delivery, reducing delivery times and operational costs. Meanwhile, air taxis are being developed as a new mode of urban transport, capable of reducing congestion and travel time. These autonomous aircraft rely on advanced AI navigation systems, precise sensors, and real-time data processing to operate safely. As regulations and technology progress, aerial autonomy will become a more prevalent and efficient solution for both logistics and passenger mobility. Autonomous helicopters are emerging as a crucial tool in search and rescue operations. These AI-driven aircraft can reach hazardous areas too dangerous for human pilots, navigating through extreme weather conditions and challenging terrains. Equipped with advanced sensors and thermal imaging, they locate survivors in disasters, providing real-time data to emergency response teams. The integration of AI allows for quick decision-making, optimizing search patterns, and increasing the efficiency of rescue missions. As technology continues to evolve, autonomous helicopters will play an even greater role in saving lives during natural disasters and emergency situations. Autonomous submarines and AI-powered ships are transforming ocean exploration and maritime industries. These vessels navigate deep-sea environments, collecting data on marine ecosystems, underwater geology, and climate patterns without human intervention. In commercial shipping, AI-driven cargo ships enhance safety, fuel efficiency, and logistical operations. These innovations not only improve maritime trade, but also support scientific discovery by providing access to the most remote parts of the ocean. As AI advances, autonomous maritime vehicles will continue to revolutionize ocean research, security, and transportation. The shift toward autonomous vehicles brings both environmental benefits and challenges. Electric and hydrogen-powered autonomous cars reduce carbon emissions compared to traditional gasoline vehicles. However, mass production and energy demands raise concerns about sustainability. Efficient battery recycling, renewable energy integration, and smart grid systems are key to minimizing ecological impact. Cities worldwide are adapting infrastructure to support green autonomous transportation, ensuring a future where self-driving technology aligns with global sustainability goals. Balancing innovation and environmental responsibility will determine the true success of autonomous mobility. As autonomous vehicles take over more driving responsibilities, ethical dilemmas arise. AI must be programmed to handle moral decisions in critical situations, such as choosing between two unavoidable accident outcomes. Additionally, questions regarding liability and accountability in crashes involving self-driving cars remain unresolved. Governments, tech developers, and policymakers are working to establish regulations, ensuring AI-driven transportation aligns with public safety and ethical standards. Creating transparent, accountable AI systems is crucial for gaining public trust and successfully integrating autonomous vehicles into everyday life. Despite advancements in autonomous technology, public trust remains a significant hurdle to widespread adoption. Many people remain skeptical about the reliability and safety of AI-driven vehicles. High-profile incidents involving self-driving cars have fueled concerns, making transparency and education key to increasing acceptance. Companies and regulators must collaborate to build confidence through rigorous testing, clear safety standards, and real-world demonstrations. As trust grows, autonomous technology will become an integral part of everyday transportation, reshaping urban mobility in the coming decades. Autonomous vehicles are at the core of future smart cities, seamlessly integrating with AI-driven infrastructure. Adaptive traffic lights, connected roadways, and intelligent public transit systems will improve traffic flow and safety. AI-powered urban planning ensures efficient land use and energy consumption, reducing congestion and pollution. These smart environments will redefine how we interact with transportation, making cities more sustainable and accessible. As autonomous technology advances, urban areas will evolve into interconnected ecosystems where mobility is optimized for efficiency and convenience. The rise of autonomous vehicles will transform job markets and industries worldwide. While self-driving technology may replace some traditional driving roles, it will also create new job opportunities in AI development, vehicle maintenance, and data analysis. Logistics and delivery sectors will see increased efficiency, reducing costs and streamlining supply chains. Industries must adapt by reskilling workers and fostering innovation to stay competitive in an automated economy. The economic ripple effects of autonomous transportation will shape the future of employment, commerce, and global markets. Autonomous vehicles represent one of the most transformative advancements of our time. With challenges and opportunities ahead, these machines promise a future where mobility is safer, cleaner, and more efficient. Thank you for joining us on this journey into the evolution of autonomous vehicles. The future of transportation is bright, and it's just getting started. If you like this video, give it a thumbs up, subscribe, and turn on notifications. See you in the next one.